Hello, welcome to join the series course, Mastering DJI Dock. My name is Irving, Solutions Engineer at DJI Enterprise. Today, we're going to continue with third lesson, Essential Safety Features of Dock. The DJI Dock 2 and DJI Matrice 3D series are designed with multiple features to ensure operational safety under extreme weather conditions. To achieve this goal, here are the key design features from hardware and software side. First, temperature range. The operating temperature for DJI Dock 2 is specified as -25 to 45 degrees, and for the aircraft is -20 to 45 degrees. These ranges are suitable for most civilian and commercial applications to ensure the flight safety. Second, IP rating. The DJI Dock 2 achieves an IP55 protection rating, which means it's dust protected and can withstand water jets from any direction. The DJI Matrice 3D series has an IP54 rating, which offers protection against dust and water splashes. Third, automatic environmental monitoring. The dock integrates various environmental sensors, including a wind speed gauge, rainfall detector, temperature and humidity sensors. These sensors provide a real-time environmental condition monitoring to ensure the flight safety. 4. Air conditioning system. The air conditioning system within DJI Dock 2 activates to maintain the optimal condition for the aircraft and the battery. Cooling system. Activate when the cabin temperature exceeds 35 degrees and terminate when it's dropped below 25 degrees. Activate when the battery temperature is above 35 degrees during the charging and terminate when it falls under 30 degrees. Heating system. If the ambient temperature is below 5 degrees, activate 1 hour before the task to heat up for 1 hour to prevent propeller icing, and activate again after the task is completed to heat for half an hour to speed up charging. If moderate or heavy rain is detected and the environmental temperature is between -5 and 5 degrees, with a flight task scheduled within 48 hours, continue heating for 48 hours to prevent propeller icing. 5. Backup battery. The dock includes a backup battery with a capacity of 12 ampere, which can power the dock for over 5 hours in case of any emergency power outage, allowing the aircraft to safely return to the home. 6. Wind resistance. The aircraft can withstand wind speed up to 8 meters per second during the takeoff and landing, and up to 12 meters per second during the normal flight operations. 7. Propeller damage detection. After landing, the aircraft performs damage detection for all the propellers, using the visual sensor to check the propeller integrity to improve the operational safety. And for the software, we will introduce 4 important safety features: custom flight areas, obstacle data, AirSense, return-to-home logic. Custom flight area. In our routine dock operations, it's important to ensure that drones do not fly into the unrelated area. Custom flight area support the creation of task areas and the geo zone, allowing the user to draw either polygons or circles. For polygons, the maximum number of vertices should not exceed 255. The minimum radius of our circle task is 10 meters. Let's see how we can set it up. First, make sure we have the project admin authorization. Then enter the project and click Map Task Area. Click the icon on the right side to start the planning of task area and the geo zone. After user confirmed the flight areas, they will be displayed during the mission planning. During the execution of flight path, if the drone comes within 5 meters of the boundary of custom flight area, the mission will be stopped and the drone will return to home immediately. When the drone is planned to pass through a geo zone between two waypoints, or during return to home journey, the drone will utilize the certain algorithm to automatically calculate the optimal detour route. Obstacle data. The value of the function is to reduce the collision risk during the mission. After enable the function, the drone will automatically avoid the model as an obstacle and plan an optimal route that maintains the safety distance from the model. The horizontal distance is approximately 10 meters, and the vertical distance from the 2D or 3D model is about 30 meters. To enable this function, first we need to import a new model and display it on the map. Then enable the function and update the data. Aircraft will automatically plan an optimal route to bypass the obstacle during flight to task or return to home. AirSense. The value of the function is to evaluate the collision risk in real time. By obtaining and analyzing the location, altitude, orientation, and velocity of the manned aircraft or helicopter, and compare the information with M3D current location, altitude, orientation, and velocity to have the air risk awareness. ADS-B detection range is 10 kilometers horizontally and 400 meters vertically. Based on the different distance between the drone and the manned aircraft, we define the manned aircraft with threats as high risk, medium risk, low risk, and display them on the map in red, yellow, and blue colors, respectively. User can also choose to turn off the medium and low risk manned aircraft threats. Return to home logic. In certain conditions, the drone will return to home automatically. Here is the logics. Low battery. When the drone's battery level is low, it will automatically initiate a return to home procedure to ensure it returns to the dock at least 25 battery life remaining. Network disconnection. If the dock loses network connection for 20 seconds, the drone will automatically return to the home. Unstable GPS signal. If the aircraft detects strong GPS interference for 5 seconds, it will automatically return to home. Strong wind. If the wind speed exceeds 14 meters per second during the mission, the drone will automatically return to home. Custom flight area. The drone will automatically return to home if the drone approaches 5 meters from the boundary of our custom flight areas. Exceeding restricted distance. The drone will automatically return to home when it flies beyond the preset altitude, distance, or the minimum height limits. To help dock operator to fly safer and get approval more smoothly, DJI provides essential documentation to facilitate the SARA process, including the technical information for the ops manual, SARA template, and the compliance of requirements, manufacturer declaration as basic containment for the SARA, and so on. Of course, all of the features we mentioned today are listed in the documentation. Feel free to download them. Thank you for your attention, and we conclude today's lesson. In the further lesson, we're going to discuss more about dock workflow in various scenarios.